Hello, guys, welcome back to the new episode of Tips and Tricks. In this episode, we will be learning about a cross platform development. What is a cross platform development? So, the cross platform development is that you are writing a code on a Windows using the C++, and you want that code also should compile on a Linux machine as well. So, for this, we will be using a CMake, a Visual Studio IDE, and a Linux subsystem, Windows subsystem WSL, by downloading it from a Microsoft Store. And let's make our life easy that we write our code using a Visual Studio, and we can compile that code from a same IDE on Linux and Windows as well, without making any extra effort of creating a virtual machine and installing a Linux, then copying your whole code to that machine and build that code, like copying, like manually copying. Yeah, the Visual Studio will be copying your code like in an automated manner, just with a one click to a WSL, and WSL build your code, and you can see the output of that code on your Visual Studio IDE. So let's directly jump into the practical part and see how we can achieve all this. So let's start by installing a WSL on our Windows machine. For that, we need to open our Microsoft Store, and then in Microsoft Store, we need to search for Ubuntu. And you can see there are multiple Ubuntu versions, light version and other version you can see. Like I have downloaded the Ubuntu simple Ubuntu version and it's already installed on my machine. Okay, when the machine gets installed, you just go in your search bar and just write Ubuntu. You can see that Ubuntu is there. Okay, so now when the Ubuntu has been opened, you need to configure the machine by installing a build essential tools, CMake, and we can see GDB as well, because when we will be running our code from our Visual Studio, then we are running in a debug mode. So on WSL, you need a GDB, which is a debugger for Linux. And because Visual Studio already have its debugger, so it will not show any error on a Windows, but it will show you an error when you will try to run on your Linux machine. So let's start setting up our Ubuntu. First, we will be installing a build essentials on our WSL. So for that, we need to write a command sudo apt install build essential. When we will press enter, it will install all the build essentials needed to build our C++ code. Then you need to install CMake. It's already installed, so it will showing you that it's already installed. And you need to install one more thing in the last, GDB. After installing all these stuff on a WSL, now we need to create a Visual C++ CMake project using a Visual Studio. So now I will directly jump on our Visual Studio. Before that, we need to go in Visual Studio installer to see what we need to install before directly opening our Visual Studio, because there is one extra package you need to install for the Visual Studio to enable this all cross platforming to build your code on Linux. So let's click on modify. Let's wait. Okay, so now you need to install one more extra thing is Linux and embedded development with C++. You need to install this package. If it's not installed, just pause the video, go install this. And other than that, you will just need the desktop development C++, and it will install everything for you. CMake, MSVC, Clang, and other all stuff has been installed. After checking this out, now we will be opening our Visual Studio. So now let's create a new project. So the new project we will be creating a CMake project. So we can see the recent project templates, or you can search here CMake. So it will show you in this. It's taking a time. So you can see that's a CMake project. So when you click this and press next, now you can name your project anything. And then I'm keeping it as a CMake project. And now I have created a CMake project. Now it's setting up all the things for me. After setting it up, now I will try to build this code once everything has been set up. Okay, now you can see it's building, or we can say generating the project using a CMake on its own. After it's done, you can just select the startup item, CMake project 2.exe. When you click run, it will run the code and it will show you the output, hello CMake. So now it has been built on your local machine, or we can say local machine is your Windows machine. Now we need to install this on our Linux machine, which is WSL. So before getting make our code compile on a WSL machine, we need to set up some stuff. So first of all, we need to go in the tools and then options, then go down and you can see a cross platform. In the cross platform, you are seeing a connection manager. In the connection manager, I have already set it up the SSH connection to my remote system, which is Linux machine. So you need to click add. It will ask a host name. It will ask a host name. Host name is the IP address of that machine. And then the username which have you specified while installing your WSL, and a password you have set it up. So in my case, I have this IP and the username and the password. And if you want to get the, we can say the, this is the machine. If you want to get the password IP, we just write down ifconfig. It will show you the IP here. Now you need to just set up it here, and when you will press the connect, it will set it up, and you can verify the connection. When you click verify, it will show you connection verified. Okay, so now how we can build this on our Linux machine. So now you can click on this local machine and you can see this 172 and this IP. If you're using a WSL, it will also shown in this drop down a WSL Ubuntu. It's the same machine, it's already set it up in your Visual Studio. But let's say we are doing for some other Linux machine, as we can say we have set it up on any virtual machine on our computer. Now when I click this, so it set it up to Linux debug default and other than everything. Now you can see some errors because a Visual Studio generate a CMake JSON build script in which we need to edit the preset. For the Windows, the generator is Ninja, but for the Linux, we are not using Ninja. We will be using a Unix make files. So now we need to go here down and we can see that all the, for example, for Linux, you can see for Mac OS, and for the Linux, you need to specify Unix make files. It already bring for you. And when you save this, you can see the CMake error generator is showing you a Unix makefile error. Why it's showing you that? Because if you have built your code using a Windows, because you have seen that it always make a copy, it always make a file all copy, make a copy of your file on your WSL machine. So now if we go on our Linux, so in our directory, we can't see this .vs folder, but there is a folder .vs. We need, when we enter into this folder and press ls, we can see there is a CMake project 2. And when we go in this project 2, so we can see a out folder. Let's go into that out folder, and then there is a build folder, Linux debug, and then there is a CMake cache. The CMake cache is making an issue. We just need to remove this CMake cache, and after removing the CMake cache, when you will be come back to this project and press generate, it will start copying the files again, and you can see it's detecting a compiler and other stuff, and the CMake generation has been finished. It means all the stuff has been successfully done on your Linux machine. So let's press select a startup project CMake project 2, and let's press a CMake project 2. So when you press a build run CMake project 2, so now you can see it will show you a Linux console window which is hello CMake. So now we can build our project on our Windows and on our Linux as well. So this is how we can build our code on a cross-platform environment, and it's really helpful when you need to ensure that your code is working fine on Windows and Linux as well. And this makes a life very much easier when you are working with a cross-platform development. Thank you guys for watching my video. I hope you guys have enjoyed and learned more about a cross-platform development using a C++. So please subscribe my channel, like, and share. Thank you guys.